Welcome to today's lesson. In this tutorial, we will rewrite complex trinomials into factored form and identify solutions of quadratic functions given a graph. So here we are, we're reviewing our complex factoring. Complex is a little bit tougher than the simple quadratics. This time a is not going to be equal to 1. And before we start factoring our trinomials, what I'd like to do is kind of work backwards. Let's take one that's already in factored form. Clearly you see the two factors, 2x plus 3 and x minus 7. And let's undo this. That's, most people use the FOIL method or the double distribution. We multiply the first terms, the outer terms, the inner terms, and the last terms. Let's multiply the first terms together. We get 2x times 1x, that gives us 2x squared. Let's multiply the outer terms together. That's 2x times negative 7 gives me negative 14x. Let's multiply the inner terms together. 3 times x gives me positive 3x. And let's multiply our last terms. 3 times negative 7 gives me negative 21. Now, most of the time when you're multiplying, when you're foiling two binomials together, the inner and the outer terms will be like terms. So we can combine them together. Negative 14x plus 3x makes negative 11x. So now we have our trinomial, and I'll write it over here. We have 2x squared minus 11x minus 21. So if we FOILed these two binomial factors together, we get this trinomial. What we're doing with factoring is we're going backwards. I'm going to give you this trinomial and ask for you to find the factors. So let's make some connections when we go backwards. First of all, you can see that to get the first term, 2x squared, it's a result of multiplying the fronts of our factors. So therefore you can see that the fronts of the factors must multiply to give the front of the trinomials. That's why I always split apart the first term of our trinomial. In this case there's actually only one option. It's 2x times 1x. And that's why the fronts of the parentheses are what they are. Next, you can see that the last terms, or the last term, 21 or negative 21, is a result of multiplying our last, the backs of our parentheses, the backs of our factors. So therefore you can see the backs of the factors must multiply to give the back of the trinomial. And that's why I split apart the last term. Now there's actually two options, 1 times 21 and 3 times 7. So I break apart the first to get the fronts of my parentheses. I break apart the last to get the backs of my parentheses. And there's one other thing I make note of, and it's this sign right here. We learned last time that this sign, if it's a minus sign, that means that my factors are going to have different signs. And you can see one of them is negative and one of them is positive, and therefore they do have different signs. So the main job today is to make the outer and inner products add up to be the middle of our trinomial. These inner and outer, the oi, I call it, the oi, these outer and inner products have to add up correctly to be the middle of my trinomial. Now these are a little bit more complex. They're not as easy as the simple ones where we could just simply take the two numbers and say how they would combine to make 11. Because 1 and 21 will not make 11, and 3 and 7 will not make 11. And the reason for that is because we have this nasty 2 over here. 2 is going to multiply to one of these four factors and then combine with the other one. And you can see which one it is actually going to multiply to. It's going to multiply to the 7, or to the negative 7, to make negative 14. Then add the 3, and there's our negative 11. But that's what we have to sort of unlock today. It's a nice little puzzle. So let's try to refactor this. Obviously, we already know what the answer is. Here it is. But let's just act like we didn't know what it was. And we know that the front have to be 2x and 1x. Now, why don't you stop writing and just watch me, because I'm going to be erasing this anyway. We assume that it's going to be the 3 and the 7. Most of the time, more often than not, the factors that are going to work are the ones that are closer together. Very rarely will the 1 and the 21 be used. I'm not saying that they can't be, but if I'm going to be an educated guesser, I would pick the ones that are closer to each other. So I'm going to pick the 3 and the 7. Now, if I happen to put the 7 here and the 3 here, and then I'll put my alternating signs 1 plus and 1 minus, let's see why this will not work. If I check my inner terms, I multiply to give 7x. If I check my outer terms, I multiply to get negative 6x. I always combine my inner and outer terms by adding them, just like I did here. And if I combine these, I get 1x. But that's supposed to be negative 11x. That's why this does not work. If the number that you get in the middle is incorrect, then change the numbers. It's not going to be 7 and 3. That does not mean that I'm going to jump to the 1 and the 21. Instead of 7 and 3, I'm going to guess 3 and 7. I'm going to just switch their spots. Let's try the 3 and the 7, and let's see why this does work. This is 3 times x in the middle, so 3x. On the outside, I've got 2x times negative 7, that's negative 14x. When I add these like terms together, I do indeed get the negative 11x that I needed. I put a little check mark to know that I've done it correctly, and now I know that I've factored things correctly. If the 7 and the 3 don't work, and I switch them to 3 and 7, and that does not work, then I'm done with this 3 and the 7, and I'm going to go to the 1 and the 21. And that's what trial and error might make you do. It might make you erase a few times until you get to the correct answer. So let's try that with some examples today. I've got 3 of them here for you. These are all complex trinomials because a is no longer a 1. It's a 5 here, it's a 2 here, it's a 24 here. Oh goodness. Let's start with example 1. I break apart my first term. Thankfully, there's only one way to get 5x squared. It's 5x times 1x. Now I jump to the back and I break apart the 6. There are 2 options to get 6, 1 times 6 and 2 times 3. I list these options for factors, and then I'm going to go and write my parentheses. Now I know that it's going to look like that. Let's see everything that I know for sure. I know that the 5x and the 1x, that's the only option for the front, so I can put those in the front right now, 5x and 1x. The only other thing that I know for sure is my signs. Because this is a plus sign, both my factors will have the same signs. And if they're both the same, then I can look at the first one to tell me what they both are. They're both minus signs. That's everything I know for sure. I'm going to change color, and that's going to be my indicator that the rest is going to be a guess. And if you'd like to just watch me do it so that you don't have to erase if I erase, that's great. I'm looking at the 2 and the 3. I'm going to choose those first because they're closer together. Now I don't know which one is going to go where, so I'm just going to put them in as a guess. So I'll put the 2 and the 3. Let's see what happens. I always have to check my inner and outer terms first. So here's my inner terms, negative 2x. Here's my outer terms. That makes negative 15x. When I add those together, that makes negative 17x. Is that what I'm supposed to have? No. The sign is correct, so don't do anything with the signs. The number is incorrect, so let's switch the numbers. We get out our eraser, and we say, okay, it's not 2 and 3. I'll just erase all this. Maybe it's 3 and 2. I'm just going to switch them. Now I get negative 3x in the middle, and I get negative 10x on the outside. Add those up and I get negative 13x, and lo and behold, that's exactly what I needed. I'll put a little check mark. I'll be happy that I solved that puzzle. Let's look at example 2. We have multiple variables in here, but that's okay. I see a 2, I see a 20. Makes me think there might be a GCF, but unfortunately, nope, there's a 3 in the middle, so that's not going to be a GCF. And they don't share the same variables in all the terms, so it looks like there's no GCF here. Let's split apart my first term. I get 2x times 1x. It's really the only option for the front. The back, I've got 1y times 20y. I could do 2y times 10y. 3 does not go into 20, but 4 does. 4y times 5y. And that's it. Those are my 3 pairs. I'm going to put my parentheses because I know that if it factors, it will look like that. I'm also going to put the stuff in the front that I know. 2x times 1x, that's the only option. There is one more thing that I do know, that the signs will be alternating. They will be different. But what I don't know is if the plus sign is going to be with the 2x or if the minus sign is going to be with the 2x. So I don't know where the signs go. All I know is that they will be different. So everything right now is going to be a guess. So I'm going to change color to imply that I'm guessing. I'm going to choose the 4 and the 5. That's what I'm going to do first. Now understand this. This is a nice way to become a more educated guesser. If I'm going to choose the 4 and the 5, the number that cannot go here is the 4. Because if a 4 goes here, or if any even number goes here, then I would have a GCF, because there's already an even number here. And since I do not have a GCF in the beginning, there will not be a GCF in the middle. So if I'm going to choose the 4 and the 5 would have to go here, and the 4 would have to go here. Now, I don't know if this is true or not. We might have to erase this, but that's what I'm going to choose first. And I know that they're different, so I'll just throw in a plus and a minus. Let's just see what happens. I multiply the inner terms and I get 5xy. I multiply my outer terms and I get negative 8xy. Add these two numbers up and I get, hey, look at that, negative 3xy. I believe that's exactly what I needed. Check mark. I lucked out and I got it right on the first try. I guess that's just called trial. No trial and error. Yeah. Okay, let's look at our last example. Oh boy. 24, 22, and 4. Well, now wait a minute. Is something talking to you about this? These are all even numbers. This is a GCF. We got a GCF to begin with. You should always look for a GCF, especially if you have bigger numbers. It'll definitely simplify your life. I see that 2 can go into all of these, so I'm going to factor out a 2. Now, it doesn't just magically disappear. It just comes out off to the side. The 2 is going to be factored out of each of these terms. So I'm left with 12x squared. This is a little bit better than 24. 11x and a 2. So my numbers are a little bit smaller, and that's helpful. Let's see what we've got here. Now, don't forget this 2. This 2 is going to be in our answer all the way in the end. Please don't forget about that. 12x squared. Oh, boy. Unfortunately, we've got a bunch of options. 1x times 12x. I've got 2x times 6x. I've got 3x times 4x. The good news is, back here at the end, there's only 1 times 2. So that's nice. Again, don't forget about this 2. That should be the first thing you write down every single time. And then I'll put my parentheses. Now, what do I know for sure? Well, I don't know for sure anything about the front, but I do know the back. It's going to be a 1 and a 2. So I can put those in here. Anything else I know for sure? Absolutely. The signs are the same. I like it when the signs are the same because then I don't have to worry about the signs. They're both the same because this is a plus. Then I get to look at the first sign to tell me what they both are. They're both plus signs. Okay. So now it's all about finding, I'm going to change color. It's all about finding what's going to be the front. Am I going to guess the 3 and the 4, or the 2 and the 6, or the 1 and the 12? Well, let's talk about the 2 and the 6, because I can rule that out right now. They're both even numbers. One of them would have to come here with another even number. Since I've already taken the GCF out, I know that another even number cannot go here. It cannot be that option. So that leaves me with 1x and 12x or 3x and 4x. I'm going to choose the ones that are closer together. And again, for this reason, the 4x cannot go here. So this would have to be a 3x. And this would have to be the 4x. Now, I don't know if this is true or not. It could be the 1x and the 12x. I'm not going to know until I check it. It's trial and error. It's guess and check. We need to check. 1 times 3x gives me 3x. 4x times 2 gives me 8x. Add those up, I get 11x. Is that what I needed? Absolutely. I know that I factored it correctly, as long as you don't forget the GCF. We've got it. I understand that this is going to take more practice. Absolutely, and that's why we're going to practice more in class. But the more you practice this, the more you realize that there are smart choices for your factors. You become an educated guesser, and you minimize the amount of erasing that you might need to do. But you do need to stick with it until you get to the final answer. Okay, let's switch gears from expressions, and now let's solve equations. Here are equations. I know because they're equal signs. Here's an equal sign. Again, this is the easiest type of problem I can give you. It's already in factored form, and it's already equal to 0. So we should be able to go straight to the answer. And I'd like to go straight to the answer, like I said in my last tutorial. Understand that the factors have the opposite sign of our roots. So we're going to take a positive, and then it's this number divided by this number. So 7/3. That's one of the answers. Let's try this guy. This one is going to be -1/2. -1/2. If you have trouble going straight to the answer, understand that what I'm doing is I'm taking this 3x minus 7 and I'm setting it equal to 0 in my head. I'm adding 7, that's why it's going to be the opposite. There's my positive 7. And then I'll have 3x equals to 7. Then I'm dividing by 3. And that's where I'm getting my x equals 7/3. Instead of having to write these steps every single time, it's the same short algorithm every single time. Positive 7/3, -1/2. I'd like for you to take the shortcut. Example 5, not as easy. It is equal to 0 at least, but we do not have a product. So we need to factor this. I see 12, I see 15. Unfortunately, 3 does not go into the 8. So there is no GCF. I'm just going to go straight into my factors. So I've got x times 12x. I've got 2x times 6x. We've already dealt with this 12 before. And we didn't like it. We had so many options here. Oh boy, we got 1 times 15. And we've got 3 times 5. This one's the toughest one yet. The only thing I know for sure is that we have 2 sets of parentheses equal to 0. Don't forget that it's still equal to 0. That's really the only thing I know for sure. Everything else is going to be a guess. So again, why don't you watch me do this unless you would like to erase with me. As an educated guesser, I choose the ones that are closer together. So I'm just going to throw the 3x and the 4x in the front. I choose the ones that are closer together here. I understand that the 3 will not go here, so that's nice. I'll put the 3 here and the 5 here. I know that they're different signs. I have no idea which one's supposed to be which, so I'm just going to throw in a plus and a minus. Let's just see where I am. I multiply the inner terms, I get 20x. I multiply the outer terms, I get -9x. That adds up to give me 11x, and that is way off. The number is not correct, so I would have to switch the numbers. But here's the deal. I can't switch the 5 and the 3 to become 3 and 5, so I don't think that it's going to be the 3x and the 4x. I'm going to erase everything that I've done. I'm going to rule out the 3x and the 4x, and now let's try 2x and 6x. 2x, 6x. I'm going to try the 3 and the 5 again with these, but again, the 3 cannot go here because there's another 3 in this set of parentheses. So I'll put the 5 here and the 3 here. Okay, let's see. I'll keep the plus and the minus where they are. Here's 18x, and here is -10x. Add those up, what do we get? We get 8x. Oh, hey, that's so close. The number is spot on. The only thing that's wrong is the sign, so guess what I'm going to do? I'm going to switch the signs. It's not plus minus, it must be minus plus. If the number's wrong, switch the number. If the sign is wrong, switch the sign. So let's see what we have now. -18x. This becomes +10x. That adds up to -8x. It's exactly what I needed, so I know that I'm correct. I'm not finished, but I am correct. Now I have a product equal to 0, and I can write my answers. X is going to be equal to positive 3 over 2. That's one of my answers. X is going to be equal to negative 5 over 6. And it feels good when you finally get the puzzle solved. It might take you a little bit of erasing, but you can get there. And lastly, I don't even have an equation. I just have a graph. I just wanted to review this. If we wanted to solve for these answers, we know that they're right here at the x-intercepts. So in this case, x is going to be equal to a 1, and x is going to be equal to 1, 2, 3, 4, 5. That's not too difficult.
So these are the solutions. Now, if we wanted to remind ourselves how to take these roots or these solutions and put them into factors, let's do that. So if one of the roots is 1, then its factor would be x minus 1. And if the other root is 5, then its factor would be x minus 5. And these would be the factors. I want to remind you the difference between what solutions look like and what factors look like. That's it. Thanks for watching. We'll definitely practice this in class. Bye-bye.